All right, today we're going to talk about one of the internet's real unsung heroes. It's the secret sauce that powers your favorite games, your video calls, all because it follows one simple, kind of brilliant rule. Sometimes being fast is way more important than being perfect. We are talking about UDP.
I mean, think about it for a second. Have you ever sent a blurry, kind of pixelated photo just to get the message across, like, right now? Or maybe you fired off a quick text with a typo because, stopping to proofread it would just take too long? If you've done that, you've already made the exact same choice that we're talking about today.
And that is the big idea here. On the internet, that philosophy is exactly what keeps your video call from buffering into a slideshow or what keeps your online game from lagging at the worst possible moment. And it's all thanks to a protocol called the User Datagram Protocol, or UDP for short.
So to really get why UDP is such a big deal, you gotta look at its counterpart. See, when you're loading a web page or sending an email, you need every single bit of data to show up, perfectly and in the right order. But for things that are happening live, in real time, that guarantee of perfection, it's actually a massive problem. It's just too slow.
Okay, so check this out. The best way to think about the two main protocols is like this. The standard one, TCP, it's like a certified letter. It needs a formal handshake to set it up. It guarantees every single piece arrives in perfect order, but it's slow. UDP, on the other hand, well, it's a postcard. You just write it, you send it, and that's it. No setup, no guarantee it'll even get there, but man is it fast and efficient.
So, whenever that need for speed just completely crushes the need for perfection, applications turn to UDP. You can think of it as the internet's own dedicated express lane, built from the ground up for one thing: low latency communication.
So what is UDP really? Well, believe it or not, it was first specified way back in 1980. It's a transport protocol that sends these little individual messages called datagrams. And here's the kicker, it's connectionless. That means it doesn't bother setting up a formal connection before sending data, it just fires it off. It's a true send it and forget it delivery system.
All right, let's get under the hood here. How can something so basic be so powerful? Well, the magic of UDP, the secret sauce, is in its radical simplicity, and in all the stuff it intentionally leaves out.
It all starts with the header. A TCP header, well, it's complicated. It could be 20 bytes, sometimes even more. But a UDP header, get this, it's a tiny, fixed 8 bytes. That's it. It only has the absolute bare essentials: where it's from, where it's going, how long it is, and a little error checking number. That minimal overhead is a huge reason why it's so incredibly fast.
The whole journey is just brilliantly straightforward. An application has some data, UDP just slaps that tiny 8-byte header on it and sends it on its way. There's no back and forth, no managing a connection. And then you get to step 4, and this is my favorite part: the packet maybe arrives. And that's not a bug, folks. That's the defining feature.
To really get UDP, you have to appreciate everything it doesn't do. It's all about what's missing, by design. It doesn't shake hands to start. It doesn't wait for a little message saying, "Hey, I got your packet." It absolutely will not resend a lost packet, and it couldn't care less if packets arrive all jumbled up. All of these things, which really slow TCP down, are just stripped away for raw speed.
And hey, this isn't some abstract techie thing that only network engineers care about. No way. You rely on UDP's speed all the time, every single day, and you probably don't even realize it.
Think about an online game. You need to see where your opponent is right now, not where they were half a second ago. Or on a Zoom call, you'd much rather miss a single syllable than have the entire conversation grind to a halt while it tries to retrieve it, right? Even just looking up a website's address with DNS uses UDP because it's so quick. In all these cases, the newest data is way more valuable than perfect old data.
And this chart just drives the point home. UDP is not some bit player anymore. It handles a massive, and I mean massive, and growing slice of all the traffic on the internet. We're talking everything from streaming and gaming to the very way we find websites.
Now, the biggest reason for this huge growth is a modern protocol called QUIC, which actually powers the new version of the web, HTTP/3. And since QUIC is built right on top of UDP, it means that today, something like 35 to 40% of all web traffic now depends on UDP's foundation. It's incredible.
So this is what's so cool. This protocol from the 1980s, it's not some dinosaur, it's actually the launchpad for where the internet is going next.
This quote right here just nails it. Because UDP is so incredibly minimal, it's like a blank canvas. This lets smart people build new protocols like Quick right on top of it. They can add all the fancy features like reliability and congestion control themselves at the application level, without having to wait for the whole internet to slowly change its core plumbing. UDP's simplicity is literally its greatest strength.
But of course, it's not a silver bullet. It's not perfect for every single thing. The advantages are super clear. It's wicked fast and easy to use. But that comes with big limitations. The application itself has to be smart enough to deal with lost data. And without any built-in traffic control, a badly written app could totally flood a network. It's a powerful tool, but you have to use it responsibly.
So look, if you take away just one thing from all of this, let it be this right here. UDP is a deliberate trade. It throws away the ironclad guarantee of perfect, in-order delivery in exchange for the blistering speed that our real-time world demands.
And that really leaves us with a pretty big question, doesn't it? From instant messaging to live sports streaming to the Internet of Things, our technology seems to want immediate feedback more than it wants flawless delivery. The whole idea behind UDP might just be mirroring a much bigger shift in how we all communicate. Is it possible that good enough, right now, is actually becoming the new definition of perfect?